All right. Hello, everybody. Just stopping the screen share over there. Just want to welcome everybody to one of our webinars. This webinar being particularly on the a deep dive into domain modeling. So yeah, just want to thank everybody for joining today. I still see we've got a few people still trickling in. So got a great turnout today. So we're very, very thankful for that. Guys, so just to get right into what we want to cover as part of today's session. So, I mean, we've got an hour and a half. We're going to get as far as we can. Domain modeling is a pretty deep world. And in the time that we've got, we're going to try pack as much, or at least I'm going to try pack as much as I can into the session for you guys. And generally, the flow is going to be to start with looking at some of the, or at least brushing up on some of the theory and key concepts behind domain modeling. Of course, we're going to draw on a lot of the DDD stuff from Eric Evans as part of that. That's where a lot of the, you could say, the language behind domain modeling in the software space comes from. We can then just get into actually creating a model. So that's when we'll jump into intent architect. We'll use intent architect as the vehicle for discussing domain modeling. And we can go ahead and model out a sample domain. I think we're going to go look at something like an eShop or something like that, something that you guys would probably be familiar with. And along the way, we're going to talk about a lot of the basics of modeling, but in a bit of depth. Okay, so we're going to go through the associations, different relationships, how those translate to different persistence technologies, particularly around relational databases and document stores. We won't necessarily look at things like event sourcing. That's something we'll do in another webinar another time once we've put together some public patterns for that. We've done some event sourcing architectures with Intent Architect. Our team just hasn't set up a, you could say, public set of patterns for that. So that's something for the future. That'll be a really awesome webinar to do at another stage. So as we go through this whole process, we'll set up this whole domain model and we'll talk about it along the way, and we'll point out all the nuances and things like that. And then we'll get Intent Architect to realize all of this for us. And the default would be to do it in an anemic way. And what I'd like to do is kind of show you guys how, when we're building a system in an anemic way with an anemic domain model, how that will translate and how that'll look. And then I'd like to switch that over and move us towards more of a rich domain model. So we'll talk a little bit about anemic versus rich domain models in a minute, but that's really where we want to end. And of course, that can just keep going deeper and deeper and deeper. So we'll probably have to cut it short at some point. So, all right. So I think without further ado, I'd like to jump right in. And let me get back to sharing my screen. All right. And kicking this off. All right. So the first thing I'd like to just chat around is why model your domain? So why go into domain modeling? The first reason for this is that a domain model provides all members of the team with a common language to communicate with each other. And this is actually really not to be underestimated. Being able to talk about your software as a team and crossing, of course, if you're building software for not developers or for not a business that you fully understand, you're very likely going to be talking to a lot of domain experts. And actually, one of the quotes there from Martin Fowler, this is actually in his in Eric Evans' book, in part of the foreword that Martin Fowler wrote, is that one of the greatest values of the domain model is that it provides this ubiquitous language that ties the domain experts and technologists together. So we'll talk about this in a bit more depth shortly, but this is one of the big value adds that a domain model does bring to the table. The second thing it does, it allows us to control and manage the complexity of our system. A lot of the, you guys have probably seen some pretty complicated systems if you've been in the software industry for some time. And one of the things that a domain model allows us to do is it allows us to abstract and distill the design of the system. Okay, and particularly when there is a correlation between the design and the implementation, it allows us to reason about it and manage that complexity in a much more effective way. And so, we all know if the complexity gets out of hand, it can become very, very difficult for the developers to handle the changes. And so a very, very key component to handling complexity is to have a good domain model that is well aligned with the business use cases, or at least the business domain and those use cases that is needed for that system. And then the final thing that a domain model also brings here is, and there's a lot of other, you could say, fringe benefits that comes with this. In fact, there's many, many fringe benefits that come with having a domain model, but it allows us to distill the knowledge of the domain in a way that is consumable to all members of the team. And it's really this crunching down of that knowledge into this domain model that allows the team to, or basically allows that knowledge to be available to all team members in a very, you can say, accessible inaccessible format. So it's a very, very important piece of the equation as well, especially if you have developers, projects when they get very large, oftentimes, if a new, even senior developer joins that project, it can take them 8 months before they're operating on the same level as another senior on that project who's been there for, say, 2.5 years already. And a lot of that comes down to that domain knowledge, and having a domain model is something that can accelerate that dramatically. So there's, those are some of those fringe benefits that come out of this as well. And then just to kind of talk a little bit around this ubiquitous language at a high level, we've got, as developers in the technical space, we've got a lot of developer jargon. We talk about, indexes and CQRS and all these different concepts that are all very, very technical. Okay, and this is the part of, you wouldn't see that technical jargon per se coming through in a domain model, at least, or in the ubiquitous language for the most part. And very similarly, if you're building an accounting system, you, as a developer, you didn't necessarily study to be a chartered accountant and wouldn't necessarily understand all the, I certainly don't understand all the nuances of accounting. And so there's many concepts there that would be considered domain expert jargon and probably wouldn't be applicable maybe to the system that's being built. So if you could imagine you're on the team for Xero, that's the accounting system, I think built in New Zealand or maybe Australia, I'm not 100% sure. But you could imagine the developers needed to understand that that's what the accountants were talking about so that they could actually build this piece of software. And really the intersection of the domain expert jargon with what the developers are talking about in relation to that system is the ubiquitous language. So these are things like the domain model terms, the names of the different bounded contexts. These are terms that, by the way, come out of Eric Evans' book, Domain-Driven Design. By the way, that book, we're pulling a lot of information out of that. You don't need to be doing full-blown DDD to get value from some of the concepts that we'll be talking about today in terms of domain modeling and so on and so forth. But it is an absolutely worthwhile book to read. I read it many, many years ago, and it definitely changed the way I look at software and the way that I analyze it. And domain modeling is something that it's a skill, and it's something that you can invest a lot of time learning, and definitely worth it from my experience and what I've seen with other guys also who've got very, very good at domain modeling. The other things I wanted to just mention here or just talk about is some of the ingredients of effective modeling. So, to do modeling in an effective way, one of the first ingredients, and very importantly, is to bind the model in the implementation. So it doesn't really help to have some kind of abstract model of the system that doesn't have a correlation, at least a very strong correlation, with the actual implementation in the code base. So very important is to bind the model in the implementation, and this ensures that the world that is spoken about in the ubiquitous language is the same world that is used, the same language that is used inside of the actual code base. It can also help us, especially with the domain model, it can help us reason about our code base through that model as well. So very, very important. Typically, you would do this manually, but of course, we've got Intent Architect, and you guys are all very familiar with that. So the binding of the model and the implementation is something that is just really standard for what we do in the space, but very important piece of the equation. The second is to cultivate a language base in the model. We've spoken about this ubiquitous language. And I think that one of the things when it comes to this ubiquitous language that is missed sometimes is oftentimes we think it's really the language for us to talk to the domain experts. But actually almost equally important is, yes, that's definitely a part of the equation, but equally important is being able to speak to each other. So whenever you're trying to flesh out a new use case with team members, you don't want to be you don't want to be using terms that are not understood in the same way by all team members, and having a model that represents these terms makes sure that everybody is in fact on the same page. So cultivating this language, continuously cultivating it, because of course the understanding of the different terms gets deeper and deeper as the knowledge of the domain and insights into the domain evolve as well. The third thing is to develop a knowledge-rich model. So typically when guys model out a domain, and we see this, even with users of Intent Architect, is to very much focus on the data schema. But in order to really get a lot of value out of a domain model, especially in more complicated domains. So of course, if the domain is very, very simple and it is very data orientated, then one doesn't necessarily need to go so far into creating a knowledge-rich model. But typically, if you're building a system of substance, and there is a couple of iterations, so you know that V1 is just step 1 along the way to V12. So we know that this is a long-term system that'll grow with the business. creating a lot of knowledge, or at least getting a lot of knowledge into that model, can be incredibly valuable for future developers, for the future iterations. So representing behavior, representing some, more of the constraints and the rules behind the system inside of that domain model, so that those are actually captured, is very, very valuable as well, and makes for very effective domain modeling. The fourth thing that we can mention here is to distill the model, and this is really a continuous process to continuously distill the model over time and isolate, concepts, or at least discover implicit concepts. That's something that Eric Evans talks about. As time goes on, you'll find that oftentimes your first pass at modeling out a system is usually very clunky, especially if there is a bit of complexity. And in the beginning, with the first draft of a model, you'll roll that out, you'll implement that, and you'll start putting some business logic, and then you'll very quickly realize that, with the first set of use cases, it was fine, but with these new use cases, we're starting to run into some friction. And so this process of continuously evolving and distilling the model as deeper insights are gained is also very key to effective modeling. And it's how we essentially have this living document that evolves over the lifetime of the system. And then finally, one of the last ingredients that we could talk about here is to use the model for brainstorming and experimenting. So when the business comes with new use cases, and the team needs to understand how these use cases affect the domain model, or if there are some new aspects to the domain that are extended in that model, talking about it and using the model as a way to essentially run those use cases and to experiment with them. So you speak through the process of, okay, an order will be created, which will trigger this and check the stock and, all those kinds of things. That can be tried and tested and judged for its, for a good fit for the design of the system through the model. So this whole brainstorming and experimenting approach is really just actually utilizing the model on a regular basis as you build out the system, and checking your sanity checking, or just making sure that your things are rational about how you are designing your system, can be achieved through just essentially talking through the domain model and brainstorming and experimenting in this way. So those are some of the most effective ingredients, and this is also just very vanilla out of Eric Evans's book. He does talk about this stuff in a lot of depth. In fact, he's got a lot of chapters actually dedicated to some of these concepts. One of the other things that he does talk about is the building blocks of model-driven design. Now, this has been, to give you an idea, I mean, the DDD book came out in 2003. And I definitely see that many concepts, it's been very, very popular. I think that guys have also burnt their fingers, very similar to all concepts in the software world. Microservices comes out, everyone's hyped up about it. A few people start to burn their fingers, and then the trough of disillusionment kicks in, and then it finds its place that the ideas that it was really bringing to the table start to find their way into, you could say, mainstream software development. And the concepts in DDD have done exactly the same thing. So very often we talk to people about value objects, entities, services. Of course, here we're talking very much about domain services in this particular case. But these are the ways that we can express our model and the relationships between these. There's obviously a few other pieces that I think we would want to add here. Another concept that DDD brings to the table is this idea of aggregates. So an aggregate is really the grouping together of sets of entities and value objects in a way that those entities and value objects together maintain their integrity. And typically, the only way that you would access the aggregate is through one of the entities, which they call the aggregate root. So that would be how you can access anything within that entity, or command it to do anything from another layer, for example. In order to create our entities and value objects, we use factory patterns. This is something that I actually don't see that often, is the actual use of very specific factory patterns. But you do see factory methods and things like that on a lot of classes, and that's using constructors and things like that. The most important thing is that whenever you do construct your entities, if you are using these kind of paradigms, the most important thing there is to make sure that all the invariants are checked, and that you don't putting your data into an invalid state in any way. And so factories are one way to obviously achieve that. And then the final pattern that one would see out in terms of these model-driven designs is the repositories. And this is really just to access the aggregates and the entities within the system. And then the other things, and I didn't want to change this diagram at all from out of the Eric Evans book, even though I think things have evolved quite a bit in terms of what architectures people would typically be using. The first is the He does talk a bit about something called a smart UI. There are a lot of similarities and quite a large overlap between the way that you would build this smart UI, which is very much just treating the data model as a data model. Okay, so there's really no behavior existing on the actual domain model. It's all just data, and the logic of the system is typically put into services. So you end up with transaction scripts. That's a pattern, by the way, if you guys are not familiar with it. That's for all of the business logic that's repeated through each operation within the system. Okay, and so he's basically one of the. If you look at the mutually exclusive choice between a model-driven design approach and a smart UI, it's basically a decision between those two. And there is a place for the smart UI, or you could say anemic models and all these other things where you're treating your data just as data. There is a place for it, and I've seen many systems being built like that successfully. So we don't judge too hard, but if I was to personally be responsible for a project that had a substantially complicated domain, I would absolutely be heading towards a rich domain, which we'll talk about in a little bit, and probably following most of the principles of DDD as part of that, just because of the benefits that it brings to the table. And the other point there is the isolation of the domain by using a layered architecture. Now, of course, we discussed in the last webinar the clean architecture. And a layered architecture that you would see, at least the traditional layered architecture, would have the dependencies flowing down from the application layer to the domain to the infrastructure. So the domain would actually have a dependency on the infrastructure. That is not how we would typically build systems nowadays. Hexagonal architecture and clean architecture advocate for a completely dependency-free domain, and that fits in actually very beautifully with this paradigm too, because the whole idea is really just to isolate the domain, to keep it completely isolated from everything else. And then the last thing we can just touch on in terms of the theory world is an anemic domain model versus a rich domain model. So anemic domain model is something that's actually coined by Martin Fowler. And really, I think that the travesty of the anemic domain model is that it can look on the surface like a rich domain model. So you'll see on an anemic domain model, it'll represent objects and relationships, and these are oftentimes named after the nouns in the domain space. So it'll be like orders and products and so on and so forth. And so it looks like a rich domain model. And so a rich domain model really isn't too much different in that sense, that it also represents objects and relationships and concepts of the domain, but it does represent a whole lot more as well. An anemic model has little to no behavior on the objects in the domain. This is a telltale sign that you have an anemic domain model, whereas a rich domain model will have all the key business logic lying in the domain. All right. This is usually typically expressed as behaviors, which we'll get into shortly. On the anemic domain side, when you are dealing with state, you are typically accessing that via getters and setters. That's also a very key telltale sign, is that the setters are available. In fact, if you are taking on a more DDD approach, one of the very common patterns, or at least approaches, that guys would take when it comes to the entities is to set all setters to private so that you don't have access to them in a public sense, to make sure that the anemia does not propagate, because it's very tempting for it to do that. And usually that's because of frameworks like Entity Framework and others that really just kind of push you in that direction, although EF has come a long way. So state is accessed through getters and setters for an anemic domain model, whereas on a rich domain model, the state is mutated via behaviors on the domain objects, and integrity of the domain is maintained within the domain. Okay, within that aggregate, all the invariants and so on and so forth will be enforced. And so one of the things I used to repeat when I was working with my teams in the DDD space is that the integrity of the domain the domain can never go into an invalid state. The integrity must always be maintained, and so all rules of the domain must be set so that, or at least any operation through a behavior on the domain must make sure that you aren't able to do that operation unless it ends up in a valid domain state. And so we'll get into this a little bit later when we get into the actual coding side of things. All right, other things about the anemic domain model is that you'll see that the business logic typically lives in the application layer or the service layer of the application, and these are very thick in terms of how much code is there. So all the business logic lives there, and you end up with a lot of transaction scripts, which is an anti-pattern according to modern Philo, which I would agree to some degree that is something you want to avoid. As I said, I've seen a lot of systems built in this way too. So I don't want to come across and seem too like I'm judging too harshly. It just depends. And I think that before we go further, one thing I could just on a little tangent here is talk about when we're looking at software systems, we oftentimes use this analogy of the paper plane contest. So let's say your system is, it's analogous to you having to build a paper plane. You have to fold a paper plane and you want to throw that paper plane. And let's say in the competition that your plane needs to fly 3 meters. If that's the case, to complete this, this stage of the competition per se, you could take that piece of paper, you could just scrunch it up and you could just throw it. Okay, so it really actually doesn't matter what you do when it comes to building that software. You can try out the latest tech. Usually, you can go wild. You can do all kinds of things that you've never done before, and you probably won't be bitten by it because it just needs to go 3 meters, so it doesn't matter. But if your paper airplane needs to fly 25, 30, 35 meters, then every last fold matters. Okay, and using the right pattern and using the right approaches that are appropriate for that particular application, its functional and non-functional requirements, is very, very key. And so when it comes to an anemic domain model, you would typically, in a very complicated system, avoid an anemic domain model and probably move towards a rich domain model to handle that complexity. That would at least be the suggestion that I would make to a team that was embarking on a journey like that. In contrast, just by the way, coming back from our little tangent there, is the rich domain model, the application layer really just defines the jobs of the software and directs the domain objects. So this layer is actually thin. So all that it's doing is it's basically receiving the request and it is dispatching that into the domain and directing the domain or instructing the domain correctly. And all the logic of how that instruction is realized and the implementation of that and the rules for that is all within the domain. And the last thing I could just mention here is that Anemic Domain Model is considered an anti-pattern. This is, you can go read up about it. Martin Vala, I think I've linked the page there if you're interested. It is considered an anti-pattern. It is quite prolific, so we see it everywhere. And as I said, you could still take an anti-pattern and build a piece of software that'll work. So, but it is still an anti-pattern and it can be avoided fairly easily if you're prepared to take the next steps and look at rich domain modeling. Just depends on your application. We don't want to prescribe that on all applications, or we suggest that would be a prescription for all applications at the same time. Yeah, so the last thing we could just mention here is that a rich domain model, if done correctly, typically delivers robust, extensible software that better controls and manages the complexity of the system. Okay, and so as the system grows, and we've seen this. To give one little anecdote is, I was actually on 2 projects in my career many years ago where the team, we all believed we were doing domain-driven development. Okay, and we had domain models and we had a lot of those principles that the effective modeling principles that we spoke about earlier. And what I found later was I actually had to do a course with Vaughan Vannon, was that actually we were not doing DDD. We had an anemic domain model, even though everyone on the team thought that we were a DDD project. We had a fully anemic domain model, in fact. And it was actually with the realization from going on this course with Vaughan Vannon, he ended up writing a book, I think a few years after we did the course with him, on implementing DDD. And we converted one of the bounded contexts or one of the microservices into a DDD format, and all the future systems that we build and microservices that we built were actually DDD on that project. We did it properly this time around, and what we saw was that where previously the bug count on the server side was about equal to that on the front end, so there was as many bugs on the back end as there were on the front end. We saw a shift, quite a dramatic shift towards the bugs actually really being found only on the front end, and the back ends were much more robust. And we were able to test those systems much easier. We were able to extend those systems much more easily, and the robustness of the system was really there, quite in black and white through the bug counts that we were seeing in the systems as we continue to build them. So it definitely brings a huge amount of value to move towards a rich domain model as part of this. So I think that let's just, that's really the theory side of things that I wanted to take you guys through. So what I'd like to jump into next is I'm going to share my monitor and we can get into actually playing around with some modeling and we can talk about some of the key concepts there. So, all right, let's kick this off. I'm going to share my full screen and I'm going to launch up Intent Architect. Okay. And we can jump into this. Let's go and we'll just get it to load over here. Let's just jump to the other monitor. Let's go and create a new application. Okay, so we're going to use the clean architecture that we used in the previous webinar. And let's just call this our webinar. And the system that we're going to build today is going to be an eShop. Okay. And we're actually in the process of just to give you a bit of context, we're actually in the process of taking the eShop on containers and building that with Intent Architect. In the kind of different formats that the Microsoft guys like to do it, so one of the Bana contexts, so one of the microservices as a DDD microservice, the other one as just a kind of more anemic domain model, and so on and so forth. And so just to showcase some of the different concepts and principles and how that can be applied with Intent Architect. So we're going to have that available at a later stage. So if you are interested, I mean, we're not going to necessarily share the code from this webinar, but we will have that available as a public repository. So we'll let everybody know, of course, as soon as that's ready. Okay, so I'm going to just bring in, let's just take the system as it is, and we can go ahead and create that. Let's just let it download everything. And I actually want to do some updates as well. So let's just get this, see where we are over here. Get this download. And so while we're waiting for this, the domain that we're really going to focus on as part of the eShop, I assume that everybody who's at least in the Microsoft space has come across an eShop, but the eShop on containers. But the general idea is that you've got a system where you've got products, at least a catalog of products, and you've got the ability to create a basket. And you can put different items into your basket, and then you can, when you want to check that out, you can check out and create an order, and that order goes through a process of deducting stock from the products that are available, and processing payments and so on and so forth, and eventually allowing administrator to ship that order. So it's actually not this, it's actually a very nice substantial domain to play with, and so I thought it would be good for our webinar today to actually use it as well. So we're going to focus in on the domain. I think before we do that, let's just go ahead and just bootstrap this application quickly, so we can just hide all the noise when we start getting into the actual domain modeling. And we're going to start by going ahead and saying, well, okay, let's just, how do we want to model this out? So we're going to start with a basket, right? So you can see now we're using terms that the business would probably use. They're like, well, you've got a basket, you've got items. We're all very familiar with this domain, but like I said, this was accounting. It wouldn't seem as obvious. So we've got a basket. We maybe got a basket item. Let me just fix that casing over there. And we can start to create maybe this concept of a product. Okay. I think that in the eShop, it's called like a catalog item. I'll just call it a product for now. And we can start setting the relationships. So we've gone and created 3 different entities. I'm going to go and create the relationship over here. Now this relationship, the basket, what we want is we want this basket to have, we want it to basically have many items on it. So you could have as many items for all the different products that you may be purchasing as part of your order. Okay. So we're going to just basically, we're going to set this as many on the target end, and you can see that it's right now many-to-many relationships. On the source end, I'm going to switch this over to be a non-collection, and so this becomes a one-to-many relationship. So one of the things that I can just talk about here is that the way that we set up our domain designer is to base it off of UML class diagram notation, and this is one of the most popular notations for domain modeling. Okay, and there's many reasons for that. One of them is that it translates very, very well to relational databases as well as to objects, and it can translate to document stores just as well. So it's a very, very clean and neat and very rich language for describing entities, the relationships between them. But we can also do a little bit more inside of the domain modeler, because the purpose of the domain designer in Intent Architect is in fact to model out the domain. So we'll be exploring some of those options as we go along. All right, so This relationship here is a one-to-many relationship. You'll see that there is a diamond over there that's black. That diamond is black because this is a compositional relationship. What that means is that a compositional, what that means is basically that the basket item, the basket is composed of a set of basket items. If we were to delete the basket, the life cycle of these basket items would be deleted with them. So it's basically to say that if something is composed, it is not something that can live without its owner, essentially. So that's the first relationship. If we were to now go and model out that the basket item must have a product. Now here you can see that this relationship is a many-to-one. Why? Because the product could be part of many baskets, okay? But the basket item must point to a single product. So what is on this? What item is this for? Okay, and so here we can see that this is now a white diamond, and what that means is that this is an aggregation relationship, and this and therefore this entity, the product aggregate, at least for now, I'm going to call it an aggregate root because it is one. This particular aggregate root can exist completely independent of the basket. So we could delete all the baskets and the product can remain. Of course, right now we set it, and this is part of the cardinality, is that a basket item must have a product. Okay, that's what the one over there means. If we wanted to make that optional, we could set this to nullable, and it can become a 0 to 1, in which case the basket item could point to a product or not. Okay, but here we wanted to basically say that this must exist, so we wouldn't be able to necessarily delete a product that has a basket item attached to it. Okay, so that's just worth keeping in mind. The other things that we can do here is we can also model out that a product may have a category. Okay, and we could also say that it is possible that a product could belong to multiple categories, and this is a many-to-many relationship. So these are aggregational, which means that once again, the product categories lifecycle and the product's lifecycle are independent of each other. If I delete the product category does not need to be deleted. Whereas in contrast, if I delete the basket, all basket items that are attached to this basket must be deleted with that. So that's how you can really read it. You can see the information is very clear to me as a developer that the life cycles are actually captured in pretty much, in black and white for us to see. Okay, literally in black and white for us to see. All right, so the other thing I could just mention over here is that we are by default, as part of this clean architecture, we are in a relational database paradigm. We don't have to be. We could also be in a doc store paradigm or a event sourcing paradigm if we wanted to, if we had some patterns that we could play with. The way that we know that is because we've got the relational database stereotype on this particular package, and that's why we're ending up with a lot of foreign keys. And so some of the implementation concerns that are linked to, you could say, more technical concerns, so things like surrogate keys and foreign keys and so on and so forth. All of that stuff is in fact here as well, and it's explicitly shown, and that's because that's an option when it comes to intent architect. At least you can have it either way, but we found that this having it explicitly available is a very nice way for all developers to understand exactly what they're looking at from a technical perspective as well as from a design and domain modeling perspective. Okay, so we can see that when it comes to this many-to-one relationship, we're going to end up with an ID on this side. So that's how to be translated into a relational database. And similarly, we'll end up with an ID for the many-to-one relationship also on the basket item. So you'll see that basically the ID, even though the relationship is this way around, the ID is put onto the basket item for which basket it belongs to. Okay, when it comes to many-to-many relationships, you see that there is no ID on either of these, and that is because this would end up with a join table in between these two in a very typical sense. And if we had to contrast that quickly with a document store, this would actually be a document. So the basket itself with each basket item would be a document that would be stored. So all of the different basket items would be stored as part of that. One has to be careful with document stores, just as an aside. If you do have one-to-many relationships, you want to be pretty certain that the number of items in there isn't going to exceed the maximum size of the document. And so you may have to put some limitations on things because of that. And also you probably will model things a little bit differently. Let's be honest about this. If you were using a document store, because you'd probably want to put a lot of the product information, for example, on this basket item. As just an aside, the eShop on containers is in fact a microservice architecture. We're building this out as a monolith. I think I should have made that clear, just because we're not trying to go into eventing or any kind of service-to-service invocation and microservice architectures. We're going to do a webinar on that in the future. Probably the next webinar we look at will probably be covering how to do all of that stuff. But today is more focused on domain modeling. So this is really the direction we're going. We can also go and model out some of the key concepts around, like let's say the basket, like how many units you wanted to put on this, and maybe there's a discount as well. So can go and add that, make that a decimal. On the product, of course, we're going to need a name and a description, and maybe how many, what's the available stock count, stock, which can be an integer, and on the product category, maybe just a name, and so on and so forth. We can essentially, I think on the basket ID, this typically be the customer ID of some sort, and maybe that's a GUID, maybe it's a string, depends on how this works. So we could change it over to be a string if we wanted to. We can essentially model out, this is the data structure that we've essentially modeled out for our system so far. Okay, if we had to keep going with this, we can end up with a few other concepts in here. So, I mean, this is not sufficient. If we wanted, we'd probably create the concept of an order. So once we go and we check out our basket, we're going to create an order. An order will have line items. So it'll be order items as well. And maybe we can just space these out a little bit better. Something like that. And I can go and do very similarly. This will be a one-to-many relationship. So many over there, one over there, and this will be a many-to-one relationship again, pointing to the product over here. Now, of course, if the product was in a separate system, so if the product itself was in a completely separate system, we would just have the product ID over here. Okay, so if you did break this apart into different bounded contexts or into different microservices, you would not have necessarily the ability to navigate from the order item to the product. You would probably just have the product ID over here. But that's something we'll take a look into in the next webinar, or one of the future webinars when we cover a little bit of how to do microservices. The order, now this is interesting. We'll probably want to have an order date, which can be a date time. And we probably want to also have like the order status. Okay, so an order status would typically be some kind of an enum. So let's go create an enum, call it the order status. I can also bring that into the domain model. Okay, so we can actually see it over here, and we can go ahead and create some, so this could, some statuses, so submitted, and we could have maybe stock, let's just call this stock confirmed. Okay, and we've got paid, and we've got shipped, and we've got maybe canceled. Okay, so all these different statuses, I think, maybe there's some that we would want to add here. One thing I just want to point out is that you'll see I'm just quickly setting the values for these. And one thing I just wanted to point out over here is that I am actually starting at 1. Okay, the reason for that is that typically you do not want your enums to start at 0. That just, it can cause, it's not that it's completely illegal, it's just that your likelihood of running into a bug if you start them at 0 is just much higher, because they're typically serialized as integers, and 0 is the default value for an integer. And so if you set your values of your enum to start at 0, you can end up with unintended consequences and bugs. So starting at 1 is nice. It's just a little trick that you can keep in mind. You tend to start at 1, maybe you can have a -1, but just don't use a 0. That's basically what the long and short of that would be. On the order status, we can just go switch this over to be our order status as well. Okay, so let's save this. Maybe just add in units, which will be an integer, and maybe the discount as well. That was as part of the order. Now, one of the interesting things here that I just wanted to point out is I probably, from a modeling perspective, and this is something that maybe wouldn't seem too obvious initially, is I would probably want to put the price, the unit price over here. And that's also because the product itself will probably have a unit price too. So we would want to actually duplicate this. And the reason for that is that, of course, the product, if you've got multiple orders in your system, and I mean, this is really just talking, if you were talking to a domain, to the business, you would ask them, well, if I had to change the unit price, would that make all of the orders update the unit price? They'd be like, no, 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 it should not do that. It should, all existing orders should reflect the unit price at which they were ordered, okay? But maybe if we had the basket had a price over here, so there was a unit price on the basket, okay, we would want that to update. Now, we don't need to do that in this case because we can just traverse into the product itself and fetch the unit price if we want to for the basket. But if we were in a microservice architecture, we would probably have to duplicate that value, okay? And if the product updated the price, we'd have to publish an event over the wire, manage and handle that event in this particular service, and we would want to update all of the basket items to have the correct unit price. We're building a monolith, so we actually don't have to do that. Okay, and I think that basically covers the majority of our domain model. I think that there are some other things I would want to add here, maybe things like a customer, okay, and their name, for example, is something we would maybe want to put there. Maybe we would have the customer ID, which in this case is a string again, and that may be because we're going to use the email address of the customer as an example, or maybe the security subject ID from like the identity system as the customer's ID. And so we can just go ahead and set that over here and say that this will have a customer as well. So that we can say it must exist. And of course, as we go through this process, one realizes more and more different concepts that will come out, like maybe the payment methods and so on and so forth. Okay, so payment method. Now, in this case, a customer would have many payment methods. Okay, this is the kind of thing that as you're modeling a system, you would be discussing. So customers have many payment methods. Do they share payment methods? No, they don't share payment methods. Okay, so it's definitely a one-to-many relationship, right? If they did share payment methods, maybe this would be a many-to-many relationship. Wouldn't make sense, but just to give you guys an idea. So with the product categories, we've established that products can have many categories, and each category can be on many products. Okay. All right, so we end up modeling all of this stuff out. I don't know, card type, maybe you would make this an enum probably, card number. What else do you need? Security number, card holder name, and maybe the expiration, which will be a date or something like that. All right, so you can see that we've kind of built out a domain model pretty quickly over here. Probably want to add things like address and so on and so forth. We'll get into that shortly. And if we push save, of course, what's Intent Architect is going to do now is it's just going to go and wire all of this up for us. Now, we've got some of the patterns already in place. So this is part of the clean architecture, which we discussed last time. So we've got the repositories already in our domain. We're going to end up with all of our different entities getting dropped off over here as well. Of course, things like the persistence and state management and the ORMs, there is a cost to that, which we don't necessarily have to pay as part of building out this domain model, because the domain model is, we are able to translate this very, very accurately into a relational database or into a document store. And so a lot of that stuff, because it's predictable, repetitive, can have modules, can have artifacts of pattern reuse, which can essentially automate all of that for us. Okay. The one other thing I just wanted to talk about is, of course, inheritance. Okay, so when it comes to inheritance, like let's just say, for example, we have this concept of a contact. Okay, now I'm starting to steal some ideas from accounting systems. We could, if we wanted to model inheritance, we could, so through Intent Architect, we create an inheritance and we just say this inherits from that. So customer inherits from contact. Now, if we run the software factory for this, one of the way that this is done by default is that we will end up with our customer. Let's just take a look at the changes that it's bringing to the table. So it switches the entity framework to have this has base type, okay? And then it goes ahead and creates our contact configuration. And what this will translate to, just by the way, is this will translate into a table per hierarchy. So if you guys are not familiar, I mean, I assume that you would be, but just in case, if you're not familiar with things like a table per hierarchy, a table per class, or table per type, or concrete class and table per type, we can control all of those things, and because those are actually technical concerns. Like, how do we want to translate this inheritance? We know that we want it. How do we want to translate this inheritance for our application from a technical perspective? And this is by default, as part of the way that the pattern would work, this by default would lead to a table per hierarchy. Maybe this would only really make sense if we had a supplier, maybe. So you've got a customer and you've got a supplier also inherits from contact, okay? And they both have a name now and so on and so forth. Now, and of course, intent architect is just going to update our model accordingly. This is a little bit, by the way, the updating of the domain model. Each time we update it, Software Factory executes, rearranges the domain model according to how we've structured everything. That is intent architect automatically binding the implementation and the domain model together. And we're basically modeling by contract at this point. And very, very, very much at this point, we are modeling around, particularly around an anemic domain model, because there is no behavior. You can see there's no behavior anywhere in the system so far. But I wanted to just point out here from an inheritance perspective, if I wanted to, I could actually change this over to, I could instruct that there should be a table over here. Could give this table a name, also call it maybe customers. Okay, and we're using stereotypes. It's the way to, essentially extend metadata in intent architect. Very, very flexible approach to doing that. And the suppliers would maybe be this table. And so we could end up with a table per type, essentially. Okay, and so here you can see that we're going to end up, it just changes the configuration. Now, if I had to run a SQL Server migration against this EF, I would end up, if I created a migration for it, you would see that it would actually go and create the separate tables for us and move away from the table per hierarchy. If I had to go ahead and make this abstract, okay, we would end up with a table per concrete in this case. And so you see it goes and basically deletes out all of the contact related stuff. And it actually just goes and puts the name and so on and so forth. All of their information just goes and puts them on the customer. So we can reuse that. It just depends on the paradigm that we want to bring to the table here. So I'm not going to get too bogged down in this for now. I'm just going to basically bring that back across, delete this inheritance, get rid of these concepts, because that's not really part of this domain. But I just wanted to talk through that very, very briefly. All right, okay, so we've covered a bit of domain modeling over here. Now, this is, of course, this is just a model to represent our understanding of the domain at this point, and this could evolve over time, and we'll get into that shortly. But let's go ahead and just open up the code base. There we go. So it's just jumping between the monitors at this point. So if you're missing a few things, it's really just I opened up the code base from the Explorer on my other monitor, and here it's getting loaded over here. And all of our different entities and so on and so forth will be inside of this folder over there. Okay. We can, of course, put things into different aggregates if we wanted to. But if we were to deal with this domain now, and this is very much an anemic domain, and the way I could just show that to you is if we had to look at our order, you'll see that, well, first of all, we didn't model any behavior. Okay, we just modeled out the data. And this is, you can see all the setters over here are essentially public. So we can just go set everything. And so the way that we would typically interact with an anemic domain model is if I wanted to just go create some CRUD services for creating an order, and maybe we wanted to do the same thing for a product. This is just an accelerator because CRUD is predictable and repetitive, so we can just take advantage of that. We can execute this, and we can take a look at what if we wanted to create this, this is the default of what, the settings would bring for us. So there's our new order. Maybe what we can do is let's just extend this a little bit and set it to also set our order items. Maybe we wouldn't want to set the status through the front end. I mean, so the front end wouldn't be able to set that. The order date, maybe we wouldn't want to set that either, but we would want to set the customer ID and the order. We can just set that over there, and we could probably just map this. Just want to map this to the domain. We would want to set the product ID and units discount. Yep, that's perfect. And we can take a quick look at how this will realize itself. So this is how it works in an anemic domain, okay? We've got our customer ID, our order items, so on and so forth, all getting set over here. And we can go ahead and apply this. And what we can do is hop back into our code base, and we can go and actually take a look at this. So I want to just walk through, just very, very quickly, I want to walk through how it works from an anemic domain model perspective. So the first thing I can do here is I'm just going to tell intent architect to leave me alone. Just tell it to just ignore the body over there. And I want to firstly just say that the order date is daytime UTC now, maybe, okay? And I want to say that the status is submitted. Okay, so we're going to just set the defaults. Now, when I create this order, however I get here, okay, so this command could be coming in from an HTTP request or from somewhere else in the system, I'm not sure. But let's just say that at this point, I need to check this order is submitted, but I do need to check that there is sufficient stock. Now, I'm in a monolithic application. I can do that pretty much in process. But if I was in a microservice architecture, I'd probably have to publish an event, which can go check the stock and would notify that there's not enough stock. And I would probably come back and actually update this order and cancel it. But let's just go ahead and do that. Let's go do a quick stock check over here. So we would want to get our product repository, okay, as a step one. And what we want to do is we essentially want to say for each of the new orders, order items, okay, that one. What we'd like to do is we'd say, let's get the product, which can be fetched quite easily for ourselves over here. So we can just fetch that from the order item.product ID, passing the cancellation token, of course. And I can say now that I would like to, so I mean, the product could be null. So if the product is null, this is a problem, right? So we'd probably have to throw some kind of an exception over here. I'm not going to just create any exceptions, but exception, thank you. Product not found. Okay, please excuse some of this stuff. You would probably not create such a bad exception in a real system, nor would you probably leave it as just exception. But nonetheless, let's just keep going. And what we want to do here is we want to say if the products dot available stock is less than the order items, what the order item units is, this is no bueno for us, and we basically want to set the order item to be cancelled. So we want to set the status to cancelled. But this is probably, I mean, let's be honest, you probably wouldn't do it like this. You'd probably say something along the lines of, let's go and extract this method. I want to check, so has available stock. Okay, and we would probably want to turn this over into a task which returns a Boolean. And we can say that if we define that, then we can say false. Otherwise, we're going to say return true. And we will do a if it has available stock, set the new order is equal dot status is equal to cancelled. Okay. All right. And so we go. So, at this point, if it's not the case, we can go and do some other stuff here. So we could probably go through and say, well, then if we can process the payments, so let's just say we want to, so var payment processed or succeeded, okay, is equal to, I'm just going to do it as a method for now. We would dispatch to some service to go and do this. And of course, you've got to be kind of careful at this point because you might have transactional concerns. So you don't want to go process the payment and then fail somewhere down here. So this is bad. If I could just be completely frank with you guys, you would not do it like this if you were going to be processing payments. You would make sure that there is a separate transaction to manage all of this stuff, or at least if there was an exception over here, you would have some kind of rollback and correctionary moves that you would make if there was an exception that happened as part of this transaction. But typically speaking, you'd probably publish an event, and that would trigger the payment processing. So that there is at least some kind of mutation, so that we have some kind of structure and separation of the different transactions. Yeah, I'm sure you guys can see here if the payment succeeded and there was a failure over here, then payment succeeded but no order created. I'm sure that that's pretty obvious from a transactional perspective. But we're just, because of what we're doing over here, we're really just going to return a true. So task dot results from results. There we go, true. Okay, so we just want to emulate this. So emulate payment, note, transactional concern. Okay, so just want to make that very, very clear. So if our payment succeeded, and I'm really not putting too much effort into making this super clean, we can go ahead and we can start doing something probably quite similar where we go through each of our products and we're going to go and deduct that stock. So product dot available stock is equal to the order item, so deducted by the units. Okay. If we were doing this as a separate transaction, we probably want to once again just check that the available stock is there, and we can go now. If this passes all through, we can go and say that the new order status is equal to paid. Now, the reason I wanted to just set this all up here is because look what's starting to happen. What's starting to happen here is that we have this is the transaction script. This is the business logic. It's starting to just basically filter into one big, long handler, and it's getting more and more complicated. There's all the different business rules. Now, if there was ever a way to create an order from a different part of the system or to do a stock check and so on and so forth, we would have to duplicate that logic, or we would have to put this into a separate service, which we would try and reuse. And so we would start having to fight a little bit when it comes to how we structure the business logic within our system. We'd have to be quite smart about it. And even if you break things apart into different methods, into reusable services, it can get to a point where it just becomes super, super overwhelming. Okay. And this is essentially what we saw. We thought we were doing DDD, but this is what anemia looks like, and this is what it leads to. Okay, is you lead to this very, very big, thick service layer with just data in the domain. Now, will this work? I hope so. It could. It probably will. I mean, I don't think I made a mistake here, but I could have. And so if I did make a mistake, it would, I mean, we would obviously come back and fix it. But I think that the main thing here is that this can get really out of hand. That's really the point I want to make. The other thing that I wanted to just point out here is that it really falls on me as the developer, whereas I'm writing this, not to forget some field somewhere here. You know, did I miss something? Like, very simply, as an example, let's go back to our model. If we were to go into our domain, I didn't want to do that. And let's just say that I wanted to create a value object. Okay, so I can't create value objects yet. Let me go into my modules and look up value objects. Let's go and install the value objects module. That'll come and update the domain, and it'll extend the domain so that now we can create this concept of value objects. All right, so let's go ahead and create this value object. And I want to call this address. All right, and we're going to create an association here, and you'll see that immediately we default this to a one-to-one. Now, if you're not familiar with value objects are essentially, as the name suggests, it is an object which is it's a group of primitives, typically speaking, that doesn't have an identity. What that means is that if we were to just swap that particular object out for another one, an equal one, it wouldn't matter to us. So address is a very common value object. There are systems, if you were writing a post office system, address could actually be an entity. Okay, but for most systems, address is typically a value object. Same as things like money. Money, you know, is an amount in a currency. And so that would typically be structured as a value object. And we can model out value objects in several ways. This is just one of them in Intent Architect. And so we can fill this in, and we can, you know, basically give this a street address. And I'll show you in a second how this affects the anemia. So if we've got a street address, we've got a suburb, we've got a city, we've got a state, and maybe a country. And I'm also coming up with more things here. So what is zip code? And so on and so forth. Okay. So this is something that we could say is required on the order. If we go and we actually run the software factory now, it's just going to go and basically bring that into our system. Now, one thing I want to point out here is that if I compile this, there's something not happy somewhere. I remember this was just one of the bugs in one of the modules. Just forgot to add the using clause. Oh, in fact, no, there isn't. Just one second. Let's quickly just fix this up. Let's go to updates. And let's just pull in some of the fixes that the team has made from some of the things that we've been doing. Just go and update that along. Okay, so if we were to build this, I'm sure that those things will be fixed. You'll notice that everything is just building right at this point. But if we were to actually run this code, what we would see is that this will break. And the reason is that address is actually set up, if we look at the order configuration, address is set up, where is it? Is required, okay? Yet we're not setting it. And so we would have to remember over here to set the address as a new address. And there you can see we've got a constructor to set this up. And that's a very important distinction also to make when it comes to anemic domain models, is that there is, because you're not using constructors and because you don't have fixed sets of parameters that are required for the developer to supply, you could very easily just forget stuff. Maybe if you had to change it to status paid, there may be other fields that we would have to set as part of this, and so on and so forth. And the developer would have to remember to do that in every place that we would change the status to paid or would create an order. And so you end up proliferating a lot of duplicate business logic rules throughout the system if you build your system in an anemic way. So I just wanted to, I mean, this is a simple example, but I hope it highlights just how anemia, it's not obvious, right? You think that this is exactly how you should program your system. But now what I want to do is I want to change gears, and I want to actually, so these are all the updates coming in. Let's just allow them to apply. And I'm sure those fixes that we applied are actually now proper fixes. What I'd like to do is I'd like to change gears and actually switch over to modeling some of this domain. Let's get as far as we can. We don't have that much time left, but let's actually switch over to doing this in a more of a rich domain model way. Okay, so first thing we're going to do is on our order, we're going to create a constructor. Okay, I can use the mapping system over here to map out that I want to be able to set the customer ID and the address. Okay, that's the first thing that I want to be able to do. I also need to be able to set my order items. So the way that we're going to do that is we can create the order without any order items, but we can go and create an operation on this, a behavior, where I can add an order item. I could, of course, have order items come into my constructor. I could do that too. But typically speaking, if I have to use this constructor, one of the rules or one of the ways that you'd want to think about this is that the constructor, if you had to use it, should not lead to an invalid object. Okay, the object must be valid. As you can see over here, if I were to construct this object, I could easily construct an invalid object using this this construction approach. Kind of essentially just hitting all these setters. And the order item over here is to add the order. So the order itself, the constructor will make sure that it's a valid order, and then I can create the order item itself as through this operation over here, through this behavior, where I can specify, for example, the product ID, which will be a good. Let's just go fix this up. And we could maybe put the units, which can be an integer, and if there is a discount, we can put it there. Decimal, and maybe the unit price, which can be a decimal, all right? The one thing that we can do here to make sure that we aren't going to make any mistakes, and this is actually very worthwhile to show, is we can go and we can just basically enable this flag over here. This comes in through the entities pattern that we installed as part of this architecture to ensure there are private property setters, all the setters are private. We can say save. At this point, if we rerun the software factory, I just want to show you what it's going to do to the system. It's just going to shift everything around for us over here. So we are, it's picking up, yeah, so of course we are changing some of our contracts, so it is going to delete some of that code there. But if we take a look at the order, notice what it's doing over here. I mean, there's our constructor coming in. This is required by EF, so that's why that has to come in. And you can see we've got some, all of these are now being set to private. You can see for the order items, it becomes a read-only collection. Okay, we have a backing field behind that, and so on and so forth. So there's our add order item over here for us to actually go and add this behavior. And so if we had to apply all of this, we can come back and you can see immediately it's not happy, right? You can't set these things like this. This is not allowed. And so by enabling the setting, I can actually force the developers into a paradigm of a rich domain, into a rich domain model. Okay, and this is one of the this is very, very key. And so it's great because, especially as an architect who is trying to encourage a rich domain, you can make sure that by default, as the team models out, that if they want to make mutations to their system, they need to actually describe those behaviors, and those behaviors should correlate to the concepts of the business. Okay, so let's just give ourselves a bit of space here. So we've got the add order item. What are the other things that we want to be able to do here? We want to be able to sorry, what am I doing? I'm not adding this. I want to be able to, let's just add another one here. I want to be able to, for example, set the order status to, so what are one of the options here? So it's stock confirmed. So set stock confirmed status. Okay. I want to be able to also set paid status and set shipped status. And I want to be able to cancel this order. Okay. And so these are behaviors that I can act on this order. I can also get total, okay, which can be a decimal. And I can go and actually fill out all these different behaviors. And we can save that. And Software Factory is going to basically go and set that up for me. So all of these different behaviors are going to be placed over here. Now, this is, we're modeling by contract here. So we don't need to necessarily express in the model how add order adds order or how the set stock confirmed. But what we do know is that these behaviors exist. And this is part of that process of creating knowledge-rich domain, is that you become aware of the behaviors that different concepts within the system can have, okay, beyond just the data structure that those concepts have, okay? So if we come back here and we started to actually implement this using our constructor, we would start off by actually using it. Okay, so we would have to set the request.customer ID, and we'd have to go and actually create the address itself. Now, we typically in a DDD fashion, you wouldn't allow this. You would probably want to pass in each individual line item. So we would probably do something more along the lines of, instead of passing an address like this, we would probably say here, street, suburb, city, what's it, state and country and zip code. Okay, we'd go and place all of those on the constructor, and we would go and specify all of that here. Okay, so one thing we can also do is, let's just go back to our services, and let's just go and adjust this. So we actually want to map this to a domain operation. We want to map it to our constructor. Okay, so we're just changing gears a little bit over here, and we can go and apply that. And now you can see that we're going to have all these options available to us. So request.street, request.suburb, request.city, request.country, and request.zip code. All right. And not happy about something. What's he not happy about? 6. What did I miss? Let's go take a look. Customer, street, suburb, city, state, country, zip. State. My bad. There we go. This is where I like this. C# has this great notation where you can do stuff like this. Let me just see if I can do it. And then something like that. Then you can just see that you didn't make a mistake. I quite like this this notation. All right, so it's constructed, and we probably want to do things like construct the address in here. So this is how we start to move the business logic into our domain. Okay. Other things that we would do here is we'd probably set the date as we did earlier. So now we're actually setting that so that that's how it'll be if you create an order. The status would be submitted, okay? And any other kind of invariance that we would want to put forward here, we would put forward, all right? Then we need to go check has available stock. Now, the thing is that when you create the order, you need to check that it has available stock. Let's just say that that's a business rule. That's part of the process. Now, what we can do here is we can say, well, I don't want to have to go now and actually instruct the domain. I could instruct the domain to go and check that, but every time the order, if I have to remember to check that there is stock every time an order is created, and let's just say there's 5 different ways to create an order in the system, it's going to very quickly become a question of, did I forget to do the checks and balances in every single operation or every single service use case throughout the system? So a better solution to that is actually to use domain eventing. Okay, so the way that we can use the domain eventing is we can go and actually create a new not value object, a new domain event, and we can create something called order created domain event. Okay, and on this I can add a property called order. Okay. And one of the nice things about the domain model, which we brought in, is that you can actually just kind of simplify these a little bit if you're not interested in too interested in what the different fields are on this, but you can do it either way. And we can actually just say that the order itself, okay, let's just drag that down a bit and put that over there. So that when we use this constructor, we can create a relationship to say that the constructor, the order will in fact publish this order created. And we can rerun the software factory execution. And what it's going to do now is it's going to go and create this. Now, it's not, intent doesn't really necessarily know exactly where to add this. So we probably want to fix it up, but we'll go fix it up in a second. And you can see that it's going creating a handler for us and the actual domain event too. Okay, so we can come back to our order and we can just, I would typically put this at the bottom. There we go. By the way, this could be a little bit noisy sometimes. You can also turn that off if you want without changing the behavior. So we can put this into implicit mode. So if we just want to, for webinar purposes, we can just go and disable all of that. So this is actually just removing all of the metadata from all of the code files. So you can see it just removes it all quickly. And so if we hop back in here, yes to all, there we go. Hold on, I think it missed something over here. Just rerun that. You just open it up again. Oh, interesting. I wonder why these are sticking around. They shouldn't be. Maybe, okay. Let's just move on. These should actually all just be removed, unless they are unique. Okay, in which case I actually think that they could be unique. Let's just remove them. They shouldn't be added back in. Yeah, perfect. Yeah, it's because we did a change, and so it does consider these to be unique because of that change, and so we only updated a little bit earlier. So that explains that. All right, so we've got this order created event. Now there's an event handler over here for that. Now what we can do is we can take this logic that we were doing over here, and we can go and basically put all of that. So let's just say the available stock. We can go grab this logic, can cut it out of here, and I can go paste it in here. And we're going to need a product repository. So let's go ahead and create that. Product repository, add it to the constructor, make it read only. And we can check here that I would want to reverse those around. Thank you. And we can go here and say, well, firstly, let's just get the order from the notifications. So, okay. And we can say if there is availability or not availability, then I want to, so if there's not availability, I actually just want to set the order dot cancel. I want to cancel this order, okay? And that could have other repercussions in the system. I don't need to worry about that. What the rules are to canceling, I don't need to worry about that, and I can return, okay? Otherwise, I can say that the order has been, stock has been confirmed, okay? Now, if we go into this, we can put some rules in here. We can say, well, and this is something that we weren't able to check earlier, but we can say if the status, I'm trying to type faster because we're running out of time, guys. There's lots of stuff I want to cover. If the status is equal to or not equal to submitted, I can throw an exception here. So throw new domain violation exception. And we can put some not allowed something in here. And I'm just going to go create this quickly. So create this type. It's an exception. Yep, that's all fine. Call this message. And we're going to just say that this talks to the base message. Yeah, so we can just go get this exception available for ourselves here, just so that we've got a domain exception of some sort. And we would probably, actually write something like cannot change order status from, whatever it is to submitted. Notice, so it's to, sorry, stock confirmed. And yeah, you'll probably do something like this. Not necessary. Okay. And otherwise, we can say that the order status is equal to submitted. Sorry, confirmed. Stock confirmed. Okay. So this is an invariant that we can enforce here. So it means that if you're not in the submitted state, you can't move through. So we're kind of enforcing the workflow here. And the only way to change the status is through this this method over here. And so now, if anyone does want to make changes, actually move an order anywhere in the system, we can be sure that this invariant is checked, and that only if it is checked will this in fact happen. And we can do the same for all of these as well. So, of course, it would probably look quite similar for all of these. So if it's paid, well, first it has to, if it's not in stock confirmed, then we want to throw an exception, and this can be go to the paid status, right? And similarly, and maybe you'd want to swap this out for the name off and so on and so forth. And this would be going to the shipped status, but it must be paid for it to be shipped. So let's put that rule in there. So this is really what we're doing here, is we're capturing the business rules inside of the domain in a way that you have to use them in order to change the domain. And that's the essence of a rich domain model. Okay, of course, there's a bit more to this. And there's not a lot of time to cover all of that stuff as part of this, but this should hopefully give you a very clear idea of how we can in fact instruct this domain. And of course, if we wanted to completely finish this logic that we've got here, let's just see, we've got a few minutes left, and I can go ahead and create a new domain event. We can call this stock, so order stock confirmed event, or domain event rather. Now we're obviously naming everything in the past tense. Let me go make it nice and small for ourselves again. And we can go and do the same thing that we did over here. We can say that, not map the order I wanted to publish. We can put that over there. And we can just essentially say that this will publish that, okay? And let's just go get this added. Yeah, so I just wanted to see what it's doing over here. Well, we actually want to know which order it is, so let's just do that. So copy that across. Yep, it should be there. Thank you. Just double check that adding this. Perfect. So one thing I can just mention as well is, I'm sure you guys would probably find this quite, it's probably worth mentioning, put that at the bottom, is you can see that I can pass this domain object into the actual domain event. Okay, that usually makes life very easy, keeps it simple. You could also pass in other things, maybe parameters, state, things like that into this domain event. But you would never push that domain event over the wire. Just want to be 100% clear about that. You would extract out the information you need, and then you would publish a actual integration event. Okay, some kind of a message that you'd pass over the wire. And you could very well do that from one of these. So you could very much, if you were in a microservice architecture, you maybe would actually publish an event over here rather than do the stock check yourself, because you want to say that this order has been created, and so the stock checking system somewhere else should handle that and actually do the stock check, and then come back and say there is sufficient stock for this order, and then we would handle that in a separate handler to set this. So it changes when you're dealing with distributed systems. Okay, microservices, you could take a problem, turn it into a distributed problem. So it does change the game a little bit. But there are patterns and principles that one can apply there to make it also very straightforward and clear what we need to do at each stage. Okay, so we've got this. We're going to set this as order stock confirmed. So let's come back to our handler. And did this thing just forget about something here? What happened to? Yeah, it looks like it did. I think we just didn't save. Just on that. Check it. Yeah. Okay, it's just removing those attributes. All right. Okay, so we don't need to do any of this stuff now, okay, because the order will be canceled. The available stock check is happening. So all of that stuff we know is already going on. All of this stuff here, we can also now move this out too. We can go and grab this information, and you can see how this is really starting to simplify what we're doing here. So let's just cut this out, because we've done that, and we can cut that. And so this is the essence when we talked about a thin application layer, okay? This is what it looks like, right? We're dispatching, or we're creating a new order, we're saving it, and we're moving on, okay? Technical concern coming in there, right? We want the database to create the ID. But what we're doing is just through the actual domain itself, we're publishing this domain event, which is then handled in such a way, so the business would tell you, well, when that happens, you must do a stock check. Now this could be happening, like I said, in a different system, or it's happening in this system right here. Do the stock check. If we don't have available, we cancel. If we do have if we do have available stock, set that to stock confirmed, at which point we now know that this handler will kick in, and we can go and not sure why that indentation isn't right, and we can go and put some of that logic that so the payment, just put this logic in here, so we can go and process this payment. Okay, and we'd probably end up renaming some of these things and so on and so forth. So we'd want to process the payment, and it will probably look something like payment succeeded, process this payment. We want to get the order, so I'm just going to call it new order is equal to notification.domain-event.order. We need a repository, and this is going to be an iProduct repository, which can come from the constructor, must be read-only. And here we can see now that we can do the check. Now, the first thing that I can just say, by the way, I just forgot is, yeah, you probably want to do this. You probably want to do something more along the lines of actually putting that rule into the domain. So you would probably have something here, like an operation that says has stock, or something like that, has stock available. As available stock. Okay, and that'll take in a number of units, which is an integer, and it'll return a Boolean, which we can put over there. And then, of course, we can also create another one here called remove stock. And this will also take in, let's just copy this across like that, take in a number of units. Okay, run the software factory. So as I said, this is not going to be a perfect implementation of this, but I'm hoping you guys can get the main gist of what I'm trying to communicate here. But we would probably end up doing something along the lines of product.has available stock, and we'll pass in the order item.units. So if it doesn't have that, and we can go and actually implement what the rules are here. So if available stock, well, we do it like this, right? Return the available stock is greater than or equal to the number of units being asked for. Okay, remove stock, we would do a if not has available stock for the units, would probably actually enforce this and say throw new domain violation exception, cannot remove stock. Okay, and otherwise we would allow ourselves to do it, so we'd say available stock minus units. Okay, and let's just go to where we were using this over here. So here we would check, here we would basically say, go fetch the product and remove the stock. This can be the order item units. Okay, so then we would actually go and remove it. And this would throw an exception if it wasn't allowed. So one thing I could just mention over here that one has to be careful of is that if you are doing like decrements and increments like this on objects, you've got to keep in mind that you are in a multi-threaded environment. So very easy, if you don't put in some kind of locking here, so either optimistic locking or pessimistic locking systems, you could very, very easily end up with an invalid number, okay, a wrong number. So it's very possible for two transactions to come in, pull out the same product. It says 10. The first one decrements it by 5. The second saves it back. The second one decrements it by 2, saves it back. The available stock is 8. It should have been 3. Okay, so just keep that stuff in mind. You'd want to implement some kind of pessimistic locking, optimistic locking, or something like that, just to make sure that that is the case. So just a little aside over there. And here we would say that the order is paid. Okay, so in essence, if we come back just to summarize here, we've got our new order that's now being created. If we were to create an order anywhere in the system, we can now be 100% certain that all business logic rules will be propagated, okay, or be at least run to make sure that the order is created in a valid state. And if not, it'll be canceled. We don't need to worry about implementing that everywhere. So if an order could be created in 10 different ways within the system, we can just use the constructor, and all of that business logic is essentially inside of the domain. And what we want to see inside of these event handlers is just instructing the domain to do certain jobs. So remove stock, set paid status, so on and so forth. Okay, so that's what we want to see. There are ways to, for example, part of these these handlers, you can actually move some of this business logic into the domain through domain services. So, things can be processed and you can just dispatch information to those domain services and they can do that processing if you want to get certain rules, if you feel like certain rules that should be in the domain are still inside of your application layer. Guys, I want to stop there. We're really out of time, but I want to check that there aren't any questions. So let me just pull up the participants and just see if anybody has any questions. Guys, just put up your hand. Happy to answer any questions. Otherwise, we'll just throw up the link and get your guys' feedback. So let me know if there's any questions anybody has. I assume that my team has answered all your questions. Okay, great, guys. I hope you enjoyed the session. Please give us a, I'm going to throw up a little QR code. If you can, just scan that QR code and head over to our survey. Love to hear what you guys thought about the session, whether you felt it went deep enough or not. So please let me know. I'd love to hear your thoughts. I hope you guys found it valuable. And once again, thanks so much for attending. That's all from me.